Good morning, everyone. I'm forecaster Jack Sillin here to discuss the severe weather setup for Friday, May 17th, 2019. Starting out with a look at our GOES 16 visible satellite imagery, we can see that we have a setup that's pretty ripe for severe weather today. We have a low pressure system here over the Rockies. To the south, there's a boundary known as a dry line, which separates warm, moist air from the Gulf of Mexico and warm, dry air from the deserts of the southwestern U.S. and northern Mexico. Off to the east, we have this boundary here. It's a warm front. And both of these boundaries are going to be providing forcing to get some storms going as we move later on into the afternoon, evening hours. So let's talk about each of those setups in a little bit more detail. Here's the dew point map. Again, it's just another way of showing those boundaries. You can see there's the boundary here separating the dew points in the 20s and 30s. That's the hot, dry air. And then dew points in the 60s, and that's the warm, moist air. And then up to the north, you can see we have some cool, dry air from Canada, and then that separates the warm, moist air from the Gulf of Mexico. So just another way of visualizing the boundary. In terms of the fuel we have available for severe weather today, there will be plenty of it. This is a neat way of visualizing how much potential energy there is in the atmosphere. This is the CAPE. So that stands for Convective Available Potential Energy, and it's the average of the Euro ECMWF's EPS ensemble. So it's basically it's a way of measuring uncertainty and seeing the range of possible outcomes. So here's the 25th percentile of CAPE. So that's sort of the lowest, a lower reasonable estimate for how much energy we can expect in the atmosphere. That even the low estimate here, that's 2,500 joules per kilogram. That's a lot. It's more than supportive of severe weather here in parts of Kansas and the Texas-Oklahoma Panhandle region. Also down to the south in southern Texas, we also have those very high values. Up farther to the north, closer to the warm front, it's a little bit lower, but still, anything above 1,000 joules per kilogram will get you a big severe thunderstorm, given the right amount of lifting and the right amount of other ingredients that you need for severe weather, and I can talk about a little bit more of those in a second. This is a map that's not often used in severe weather forecasting, but it's actually really important, and it's the 700 millibar temperature. So 700 millibars, that's sort of the lower to mid levels of the atmosphere. Think like 5 to 10,000 feet above sea level, so 4 to 6,000, 6 to 8,000 maybe feet above the actual terrain, the ground level here on the high plains. Now, why is the temperature at this level important? Well, if it's warm up in this layer, it's harder to get air parcels from the surface up to rise all the way into the upper atmosphere. So imagine you're an air parcel at the surface, and you're rising up, right? You're cooling a little bit, but slower than your environment's cooling, so you're positively buoyant. But then all of a sudden you get to this warm layer, and no longer are you, warmer than your environment because you have this warm air aloft, and then you stop rising, and you can never form into a thunderstorm. So it's basically, this is what we call the capping inversion. It sort of puts a lid on thunderstorm development, and the air parcels below it can't necessarily bump up and get through so that they can take off into the upper atmosphere. There's going to be plenty of capping today, especially down across parts of Texas, and that's what's going to make this forecast really tricky, is deciding whether we can actually get even a thunderstorm at all to develop in Texas. Can we even get a thunderstorm to take advantage of the environment? Because it doesn't matter how loaded your environment is if you can't get a thunderstorm to take advantage of it. Farther to the north, there's no doubt that the warm front combined with the very strong disturbance, upper level disturbance blasting on out here, will be able to bust through the cap in parts of Nebraska and Kansas. It's really more of a Texas question where the forcing isn't quite as strong. So here's our ECMWS thunderstorm composite map. It's a great tool to visualize thunderstorm forecasting. I'm going to zoom into two regions here. We're going to start in Texas. And this is for 8 o'clock Eastern Time, 7 o'clock Central this afternoon. And you can see that there's plenty of instability here. We showed that in the last map. And then also plenty of wind shear. So you can see strong southeasterly winds veering off to the west, southwest with height. Very strong winds, especially as you get farther north. Down south, the winds aren't quite as strong, but still more than supportive of strong to severe weather, even in parts of far southern Texas in here. So if you got a thunderstorm to develop along this dry line, it would undoubtedly be a supercell. It would be capable of damaging winds, large hail, maybe even a tornado. Farther to the north, we'll be looking for thunderstorms to develop both along the dry line and along the warm front in Nebraska. These storms will be damaging wind, hail, and tornado threats as well, but also producing heavy rain. And because the forcing is stronger, you're going to get more thunderstorms, which raises the odds that they're going to interact with each other and sort of form more clumps than individual storm cells. So, something to think about if you happen to be out chasing today. With that in mind, we'll take a look at some of our convection allowing models, their simulated radar. Of course, these products are only as good as the models themselves, which aren't all that good. But it'll help to highlight maybe some of the things that I've been talking about in a way that's sort of more familiar, which is the radar imagery. So this is the HRRR's forecast for Texas. You can see a couple of thunderstorms get going here along the dry line. This is 7 o'clock Eastern, 6 o'clock Central, but they sort of fade out, and because of that capping, they can't really establish themselves. And then this model has nothing initiating up on the dry line. The NAM model is sort of similar. It takes some showers up on the dry line, but can't quite get them going because of the capping inversion. It remains to be seen. The models are coming down on the side of too much capping to get thunderstorm development. I think personally we'll see at least one big cell go up today in Texas, but it's anybody's guess as to exactly where that happens. Farther north in Nebraska, no shortage of thunderstorm development opportunities here. We'll see storms erupt a little bit earlier in the day, given that we have all that forcing from the upper level winds, or the upper level disturbance and the big trough coming in. It'll start out as supercells, and then they'll sort of merge into more clumpy, linear segments as the day goes on. You can sort of see that evolution here in the model, right? You start out with these lovely lone supercells that are moving rapidly off to the north and east, and then by the time we get later on into the evening, you see these sort of clumpy bowing segments, which is going to mark a transition in threat from large hail, tornadoes, and damaging winds to a more primarily damaging wind threat. So keep that in mind if your plans take you out to Nebraska, Kansas, and even parts of southern South Dakota today. More severe weather is coming tomorrow, and I'll have another video on that, or at least some tweets on that tomorrow. Thanks for watching, and feel free to use the tools that I've showed you here, WEATHER.US and weathermodels.com, to explore the severe setup and the forecast for your town in a whole lot more detail than what I can cover in a few minutes of video. Thanks for watching, and have a great day.